Question 2a, we've got a cubic here, and it says, sketch the gradient function for this thing here. Now, this is very, very straightforward. They don't expect an awful lot here. Like, you don't have to come up with the equation for the function, anything like that, but we can do things pretty simply here. The first thing we want to do is recognize where it cuts the x-axis for these things. So first of all, we've got a maximum negative point, which is here. This is our as a turning point there. We've got a turning point right there. Yeah. So they're the first two things we need to actually make a note of. So what is the x values there? The x value for this one here falls, and I think the dotted lines or something like that are going to really help you out. So you want to just show that you know. Now, I've actually missed this point here. I'm actually slightly off to one side. I don't want to do that. I want to have this so it's as good as it can be. Let's just restore that line on the top there. So there is our 0 point. So I'm actually going to try and do a dotted line. And the dotted line has to fall and go down, and we mustn't miss this time. Here we go. So there it is. So there's our first point. So the points of intersection on the x-axis must coincide with this because we're about to draw the gradient function. In other words, what's the value of the gradient here? Because we're no longer drawing f of x, we're going to be drawing f dash x, or if you like, the m. In other words, these are gradients now. We're not plotting x's versus y's, we're plotting x's versus gradients. So I'm actually going to do it on the same graph. I'm not going to do it on a separate graph here. So here's our first point. That gradient is equal to 0. Here, for the x value for that, there is my 0 for this x value. What about this x value here? Here it is. Let's have a look. And we've got, there it is. I'm going to try and draw this about the same if I can. So here's my, there it is right through there. And there is my x value. So my x value here, my y value for here is 0 because the gradient is 0. So these are now not x's versus y's, this is x versus m. So this is also a positive cubic. Therefore, it will result in positive parabola. Okay, so we're going to draw a positive parabola. Now we have one more thing which we do know, and that is halfway between here and here, we have the point of inflection. And the point of inflection looks like, see here, it's a bit more up there than down here. So I don't think they're going to worry about this, but you really want to make this, the point of inflection would be roughly halfway between, and I think it's going to be about there, yeah? I think there's about the point of inflection, halfway between, and it's going to be about somewhere in line with this here. So the point of inflection is where it stops being negative and starts being positive. Here we go, point of inflection, somewhere down there. That's my point of inflection, and it's going to go, so it's going to be something like this. Let's see. So for this value here, we're going to have a gradient of about 3 or 4. So it's going to look something like this. You're going to really make it turn here. Here we go. Arrows on the end. And that would be my answer. It's not perfect. In fact, it's far from perfect. And certainly this actually should extend way up into over here as well. My one does not. What would you do here? Yeah, I would probably even have this going like up here, yes? The reason it's got to go up there, the reason is because when you take a value like this one here, you're going to say, well, what is the gradient at that value there? The gradient is about a 1. So here the gradient has to be about a 1. What's the gradient here? The gradient here is about, let's say, a 5 or 6. So at this point here, it's got to be like, sorry, at this point here, it's got to be like a 5 or 6. 1, 2, 3, 4, 5. It's got to be about there, yeah? So that point there has to line up about there. So you do want to make it look roughly like that. Anyway, that would be roughly my answer, and that would be why. Yeah. So again, you do want to do that, but they're not going to worry about that. They're just going to say pass through this point, because these are the x values when the gradient is 0. And this is a 0 for the y, or for the, in this case, the m. And that's what I would draw. Hopefully that makes sense.